I mean, here means the gap. See what is this? You're not going to all the five of you come straight out. Maybe the
hear me? Am I audible? Can you hear me?
it's impossible.
Hello, can you hear me? Am I audible? Raise a thumbs up if I'm audible. All right. Right. So we did in the last class about the motion in a straight line, right? And distance displacement we did. We solved some questions related to that. Rest we did the speed and velocity and average velocity we did, right? After that, we solved some more questions based on average velocity, and we got to know that average velocity in case of two equal time interval is v1 plus v2 by 2, and two equal displacement is 2v1 v2 by v1 plus v2, right? Agree, everyone? See here. We'll be starting with a question.
Sir, they are not
Everyone
audible.
focus on here.
Sir, you are not audible.
I'm not audible.
Yes, sir.
Can you hear me now? Is it fine now?
Sir, your voice is so low.
1 minute.
Just tell me. Okay. Okay.
Sir,
1 minute, 1 minute. I'm just checking it out.
Mithil. That's 7 minutes. That's 7 minutes. Our voice like rice power. That's 7 minutes. But you know, the disturbance are one of. Yes, true.
Hello, am I audible now?
no, sir.
Still no. I think this is fine from my side. Can you check your connection once?
Now it's clear, sir.
Now it's clear.
Yes, sir.
Shall we start?
Yes, sir.
Okay. So today we'll be starting with a question. I hope you must have solved some questions related to the topics that we have done. So question says that a body traveling along straight line traverses 1/2 of total distance. See, everyone focus on here. What does this question says that I'll explain you, you'll have to solve this yourself. The question says that for a journey started from point A, okay, and ended at point B, was divided into 2 equal distances, okay? First part, traveling along a straight line traverses 1/2 of the total distance with velocity v0. So let us say that this total distance is s, and this is s, 2 equal distances. So first half of the velocity, the body traveled with a velocity of v0, first half of the journey. For the second half, what the velocity did, the second half got divided into 2 equal interval of time, t and t. Okay, 2 equal interval of time, may not be like same distance. I can draw it like this better. May not be same distance. If it is talking about 2 equal interval of time, so it may not be the same distance. And the first half time was like traveled by v1, and second half time it was v2. See, you can cover more distance in equal time if your velocity is more. Okay, it doesn't mean that if you are traveling equal time, that means this distance and this distance is same. That doesn't mean that. You'll have to understand this. Okay, if time intervals are same, it doesn't mean that the distance traveled in those intervals are also same, because what is distance? Distance is velocity into time. So s1 is v1 into t, s2 is v2 into t. In both the cases, times are same, but if velocities are different, the distance traveled will also be different. Okay, so in the whole journey, you have to find the average velocity in terms of v0, V1 and V2. Try to solve this. Try to solve this, everyone. Try to solve this, everyone. This question you should have solved by yourself at home. You're not solving questions at all. And this won't help you in gaining concepts over physics. That is not good. If you want to do something, crack some examination, you'll have to work with physics. This is the most crucial subject. And nobody can make you the best in physics unless you want that.
Second line.
Which line you're asking about? Tell me, I'll read it out.
Second line, sir.
A body traveling along a straight line traverses 1/2 of the total distance with a velocity v0. Remaining part of the distance was covered with a velocity of v1 for first half time and v2 for the next half time. Find the average velocity.
Okay, sir.
Have you written the question? Do it fast.
Velocity.
Done? Shall we move to the solution part? Shall we move to the solution part?
Yes, sir.
Okay. So see here. So basically this says that a body traveled from point A and reached point B. Focus on here, everybody. So for first half distance, initially the journey was divided into two equal distances. And two equal distances does not mean that this is equal time intervals. Okay. So both are different things. This is V0, and the second half time, let us say from O to B, this journey was divided into two equal time interval, T1 time and T2 time. Okay, so this is V1 and this is V2. For example, let us say that at O you were traveling from A to B, and at O you recognize that you are late. Okay, so you will make yourself fast. So you'll travel some distance with time T1. So this was equal T1 and T1. You will make some. You'll be fast, and you'll be covering the smaller distances in greater distances in the same time. And then you realize at this point that you are now reaching the destination earlier, so you'll slow down. So at the same time you'll cover lesser distance. It depends on the velocity. So equal distance covered does not mean that you are covering those equal distances in equal time, and equal time covered does not mean that you are covering the equal distances. Okay, so if we divide the whole journey, yeah. Any doubt?
Sir. It's
What,
not.
Vishwam?
Sir, can you repeat again, sir?
Yeah, please focus on here. I can see you talking. Focus here, then you'll understand everything. Now see here. We started the journey from A and we have to reach B, right? In the meantime, what we did for the first half distance, for example, let us say that A to B was 100 kilometers. I'm just taking an example. A to B was 100 kilometers. For the first 50 kilometers, we traveled it with a velocity V naught. That was a constant velocity, right? Now, for the next 50 kilometers, what we did not see the distance. We divided the next 50 kilometers in two equal time. Like for the first hour, what we did, we traveled with velocity V1 and we covered some distance. We don't know what that distance was. Again, Yashwant, you're talking. You're not focusing on here. And then for the second half time, again 1 hour we took, but that was a different distance covered and with the velocity V2. So now 3 velocities were changed during the course. We have to find the average velocity. So first, somebody tell me what is the average velocity you get when you divide the whole journey in 2 equal distances? Tell me, what is the average velocity you get when you divide the whole journey in 2 equal distances? Anybody? If it is 2 equal distances, don't we get the average velocity is 2 v1 v2 by v1 plus v2? You remember that? Are you getting this point or not? Say yes or no. Are you getting this point? Yes or no? If it is 2
Yes,
equal
sir.
distance, the first half distance and the second half distance. Let us say that velocity here was v. Let us name it something different. Let us name it something different. Let us say velocity was va, and here average velocity is vb. So if it is 2 half distance, the average velocity is what? 2 va into vb by va plus vb. We did it in the last class. Yes or no? Nobody has revised. That is too. I'm too amazed by this. How will you get physics after this? See here, we just like did it in the last class. If we are traveling 2 half distances with 2 different velocities, the average velocity that we derived was 2 v1 v2 by v1 plus v2. Check your notes. Didn't we do this in the last class? So with that, if you follow the same thing, so velocity for the first half is v naught only, and for the second half it is divided into 2 equal time. And the average velocity when we used to divide the distance in 2 equal time interval was v1 plus v2 by 2. So second half was divided into 2 equal time interval. Here average velocity, that is vb, will be v1 plus v2 by 2. Okay, for the second half time, because the second half was divided into 2 different velocities, v1 and v2. Okay, so now instead of vb we'll be writing this, and instead of va we'll be writing v naught, because for the first half time it was only v naught. So total v average will be 2 into v naught, and instead of vb we'll be writing v1 plus v2 by 2 by va, that is v naught plus v1 plus v2 by 2. If you solve this, you'll be getting 2 v1 v2, 2 v naught v1 plus v2 by 2 v naught plus v1 plus v2. Did you understand this, or shall I explain it again?
Explain it again, sir.
See here. First, what we did, we divided the whole distance in 2 equal distances. Okay. The first distance was v naught. First velocity was v naught. second equal distance, that too got divided into two equal interval of time. So for this two equal interval of time, we'll first calculate, our step one will be to calculate equivalent average velocity for the second half distance, and that is v1 plus v2 by 2, that is vb, because it was equal interval of time, right? Now vb we know, and for the first half we have only velocity v0, and that is divided into two equal distances, so we'll apply it here, the average velocity for two equal distances, and that is what we get after solving. Now did you understand,
Yes, sir.
everyone? Please revise and come, otherwise even I won't be able to do anything. If you won't revise things, if you will just be blank about the previous knowledges that we have done, so that is something that cannot be done. Nobody can do anything after that.
Okay, sir.
You'll have to take physics too seriously, too much, and you're taking it too lightly instead.
Good before flash, sir.
Yeah, 1 minute, I'm just copying it out.
Okay, sir.
Is there anybody who did not understand this question? I'll repeat it again. Anyone, just raise your hand.
இது கரெக்டா இருக்குதா?
அதுதான் சார் வச்சேன்.
இது அவ்வளவுதான்.
சரி.
கரெக்டா?
அதுதான் சார். இதுல குறைச்சிட்டு ஃபுல்லா வச்சிருந்தேன் சார்.
இது இவ்வளவுதான் இருக்கணும். நெக்ஸ்ட் டைம் பாருங்க, கெமிஸ்ட்ரி கிளாஸ்
Is it done? Shall we move on to the next part? All
No,
right.
the wait. Then, sir.
Fast. Done? Is it done?
Done, sir.
All right. Next, you see. So we did average velocity. Now we'll be learning a new term that is called acceleration. Okay, acceleration. What is acceleration? That is rate of change of velocity. Rate of change of velocity. That means change in velocity per unit time. Right? So rate of change of, that is change in velocity v final minus v initial by change in time t final minus t initial. The same thing we write it as delta v upon delta t. Delta means change. This is called delta. Delta means change. Small change in velocity, small change in time, that will give you acceleration. Right? You know what is differentiation? You know what is differentiation? Have you learned about differentiation?
No, sir.
No, differentiation yet you didn't. Okay, differentiation also we'll have to do. All right. In maths that you have to learn, but differentiation is a part of maths. Okay, maths also we have not started yet, now. Right. Okay, okay. I'll have to teach a differentiation then. So differentiation is a term that is used to describe small change, very small change, minute changes that we cannot even notice with our naked eyes. Okay.
Okay, sir.
Right. But before that, we'll be learning with the terms. So acceleration, velocity, distance we learned. So now we'll be doing the equations of motions. Equations of motions. So basically we have three equations of motion. One, v is equals to u plus at. Second, s is equals to ut plus half at square. And third, v square is equals to u square plus 2as. These are the three equations of motions that are there that we have to study. Okay.
Okay, sir.
So first we'll be deriving them. Or derivation, I think basically you know that. Derivations are, I think that you must have done in school. So we'll be just using them basically. Okay, we'll be seeing how to use them in our date, like in each and every question. So what is V here? I'll be writing V like this. Always remember, I'll be writing V like this. V and U has got different meanings.
Final
I'll be
velocity,
writing V
sir.
like this. Final velocity. V is final velocity. U is initial velocity. U is initial velocity. A is acceleration. Basically, we'll be studying about the constant acceleration. The acceleration will not be changing in our case. Okay. And T is time. You know one thing? You know one thing? What is rate of change of displacement? Who will answer? Rate of change of displacement?
Velocity, sir.
Velocity. What is rate of change of distance?
Speed, sir.
Very good. What is rate of change of velocity?
Acceleration, sir.
And what is rate of change of acceleration? What if acceleration is changing with respect to time?
Sir, we don't know,
Rate
sir.
of change of this you won't find in any book. Acceleration is jerk. Jerk. Do you ride bicycle? Did you anybody of you have ridden that bikes or cars or something like that?
What's it?
I don't think that you are allowed to drive bikes, but have you ever tried?
No, sir.
Okay, bicycle,
Yes, sir. We rode bicycle, sir.
right? So whenever you try to increase your speed, what you do? You accelerate, right? You
Yes, sir.
accelerate because your speed is changing with respect to time. And when you accelerate, you do not accelerate with a constant acceleration. You do not change your speed constantly same. Okay,
Yes,
you
sir.
change your speed randomly. That means your increase in speed is different at different time. And that
Yes.
change is specially observed in case of a speed breaker when it comes in front of you, right?
Yes, sir.
So that is when you get a jerk or any irregularities come in the road, then you get a jerk because that is something you get suddenly. So rate of change of acceleration is called jerk. Okay, this is not for calculation purpose, just for knowledge. Got
Okay,
it?
sir.
Right? Written, everyone? Shall we move on? Tell me when it is done. Tell me when it is done.
Sir, done, sir.
Okay. Same equations of motion under gravity. That means either you're going up or you're falling down. Motion under gravity. Okay, in those cases, just the acceleration part changes. V is equals to u plus gt. The acceleration is being provided by the acceleration due to gravity. S is equals to ut plus half gt square.
T square.
Right, and v square is equals to u square plus 2gh.
2gh.
What you have to consider is just the directions. If you are able to find the directions correctly, the providing the vectors positive and negative correctly, rest is done. This chapter is over. That's it. You just have to provide that vectors positively. And if you are able to do that, if you are able to figure out that where to provide the positive sign, where to provide the negative sign, then you can solve any question of this particular chapter, and that will get with practice. Physics
Okay,
is
sir.
all about practice of questions. No theories required, no derivations required. You just need to practice more and more questions.
Okay, sir.
See, JEE examinations or NEET examinations have been held every year since last 30-40 years, and still there are very less chances of question repetition. Okay, so you can see how much the consistency has been maintained. So every year new questions are there, and you can find nearly no repetition. Especially in case of JEE, you would never see any questions getting repeated in JEE Advanced.
Okay, sir.
So you'll have to take it very seriously. Okay. Now see,
Okay,
here
sir.
we'll be trying to solve some questions related to this, and then we'll be understanding how to apply these formulas, right? So the first question, I'll be starting with a very easy one. And question goes like this. A jet plane starts from rest. I'll be writing the question. A jet plane starts from rest with an acceleration of 3 meters per second square. With an acceleration of 3 meters per second square, right? And makes a run for 35 seconds. And makes a run for 35 seconds before taking off. Before takeoff. Okay. So you have to calculate two things. Calculate runway length. How much runway length is required? Second, velocity before taking off. How much was the velocity attained by the jet before taking off? You have 3 minutes to solve this question.
Okay, sir.
The boy or girl who solved most questions today will get compensation for not doing any homework through the next class.
Okay, sir. Sir,
Yeah, did you get the answer?
sir, V is equal to 105 meter per second, sir.
1 minute, let me check. V is equals to 105. Yeah, that's correct. And the distance traveled?
The distance of the runway is 1637.3.
1600.
1837, sir.
Yeah, exactly. 1800.
Yes, sir.
Everybody solve this? This is correct answer.
Sir, no, sir. Still some of them are solving, sir.
Okay, okay. 1 more minute and I'll be solving it.
Okay, sir.
Okay, I'll be doing it. See here, basically, this is the plane, okay, and this is the runway, and it run off for some distance. Let us say that distance is s, okay, and then it took off, right? So it left here. So initial velocity u was 0 because it started from rest, and here we have to calculate the velocity v that we don't know. Okay. So first of all, if we write the equation of distance, that is s is equals to ut plus half at square, that we know basically, and here u is 0, right? Acceleration we are provided, that's correct. Correct. And time is also provided to us 35 seconds. So if you put s is equals to just half at square, you'll get this distance. That is 180, 1837.3 meters. Right? This is the first part. Everybody understood or not?
Everyone answered, sir.
Okay, okay. I did not hear that. Sorry. Then what we have to do? This final velocity v is nothing but v is equals to u plus at. We are given with everything. U is 0, a is given to us, time is given to us. From there you can get final velocity, that is 105 meter per second. Okay, so Yashwant answered this for the first time. I'll be considering him. Next question. Let me find a good one. Right. Question says that a man is S is equals to 9 meters behind the door of a train. Behind the door of a train. Okay. When it starts moving, when the train basically, when it starts moving, with an acceleration of
Sir,
acceleration of
can you zoom in?
zoom it. Okay, 1 minute. Let me write it, then I'll zoom it because
Okay,
the
sir.
whole system is like this only. I'm reading it out. By then you can write a man is S is equals to 9 meter behind the door of a train. Okay. When it starts moving with an acceleration of 2 meter per second square, the man runs at full speed. Runs at full speed. So how far does he have to run? Does he have to run? And after what time? And after what time he gets into the train? He gets into the train. Also, you have to calculate what is his maximum speed. So question says that a man is 9 meters behind the door of a train. A man is 9 meters behind the door of a train. When it starts moving with an acceleration of 2 meters per second square, the man runs at full speed. How far does he has to go? Run, and after what time he'll be getting into the train? That is what you have to calculate. You also have to calculate what is the maximum speed of that particular person. Do it.
Ah, 3, this is so time 3 second velocity 6 feet. So that
Sir,
Yeah.
Sir?
Did you get the answer? Did you get the answer?
time 3 seconds, sir.
How much? 3 seconds.
Sir.
No, 3 seconds. Yeah, that's correct. Time is 3 seconds. Okay. One part of the answer is correct. Good.
Velocity is 6 meter per second, sir.
Velocity is 6 meter per second. That's also correct. And distance traveled? What is the distance traveled before reaching the train?
you 9 feet is up. Right?
9 meters, sir.
9 meters.
Yes, sir.
No.
U plus 8 U.
Check your answer again, Yashwant. It's not 9 meters.
Sir,
Hmm.
9 meter only coming soon. You start doing this.
Okay.
Yes,
So
sir.
your man ran only 9 meters, right? Okay, see here, first of all, as we know that we'll be writing with the second equation of motion, that is s is equals to ut plus half at square, right? So this is the distance traveled by the train in time t, okay? And the train started with 0 initial velocity. So it will be half at square only. Acceleration we know, half into a is 2, and time that we don't know, t square. And the distance traveled is how can we go with that? How can we go with that? Okay, we shall do it in a different way. 1 minute. See, if I do it like this, then I think I'll be getting it. Okay. See, basically what had happened, this was the train and this was the door, right? The man was 9 meters behind the door. 9 meters behind the door. Okay. And then the train started accelerating. So let us say after t time, after some time t, the man and the train door of the train are at same position. So let us say that this train traveled s distance. This train traveled s distance from here to here. I'm taking the distance s. The train traveled s distance. How much distance the man traveled? The man traveled s plus 9 distance. Agree? Yes or no? In the same time t, the man traveled s plus 9 distance. T is equals to 0, they were there. T is equals to 0 and t is equals to t seconds. They both are at the same position. So yes or no? Put a thumbs up. Do you agree with this? Do you agree with this? All right. So I'll be writing the equation for this train. So train equation is what? Half into g into t square, because u is 0. Initial velocity of the train is 0. So s will be equals to half into g into t square. Okay.
Yes, sir.
But the man did not accelerate. The man had a constant velocity. It ran with a constant velocity. Though this was for train. So distance traveled for man is what? So he traveled for v into t, right? He started here with a velocity v and ran for t time. Agree?
Yes, sir.
So what man traveled, distance traveled by man was distance traveled by train plus 9 meters. Yes or no?
Yes, sir.
So what is distance traveled by man? That is v into t. Distance traveled by train is half into g into t square plus 9. Understood? This is one of my equations. Right? Agree with this or not? This is one of my equations.
Yes, sir. Correct, sir. Yes, sir.
Right? Next is the relative velocity between man and the train was. Train was accelerating with an acceleration a. If train is going with an forward with an acceleration a, that means for the train it will look like the body is going backward with an acceleration a. Yes or no? Yes or no?
Sir, can you repeat again?
If the train is going rightward with an acceleration a, that means inside the train you will feel that this man is going backward with an acceleration a. Right? Did not understand. I'm telling it again. Focus on here. If the train is going forward with an acceleration a, that means if you are sitting inside the train, you will find that this body is going backward with an acceleration a or not. Yes or no? Yashwant? Understood or not? Any doubt there? Put a thumbs up if you have understood. Can see here, basically, what I am saying is that if you are inside the train, what do you say? Can you hear me? Hello, am I audible?
Yes, sir.
Why are you not responding then? Okay, so thing is that when the train is going forward with an acceleration A, if you're sitting inside the train, you'll find that this man went backward with an acceleration A, because you will find yourself to be stable. Yes or no? Did you get it or not? Tell me yes or no. And there is a theory that if this and this has to be at the same line, that means velocity attained by this train, velocity attained by the train, attained by train should be equals to the velocity of man. Then they will be able to cross each other. So velocity attained by train t time is at, v is equals to u plus at, and u is 0 for the train. So velocity of man is vm, let us say. So in that case, we can say that at is equals to vm. This is another equation. So did you understand this? And then you have to put that here. This is velocity of man. So you have to put it here. Put it here. So at into t is equals to half gt square plus 9 meters. And then you have to solve this equation. At square is equals to half gt square plus 9. Okay, then you put the values. Acceleration is 2 meter per second square. T we don't know. This is 2 into t square is equals to, let us say 10, g is 10. 10 by 2 is equals to plus 9. It will be 2t square is equals to 5t square plus 9. So if you take it other way, it will be 3t square is equals to 9. One minute. 5. Okay, 1 minute. This equation was written wrong. Just took it a negative side on that side. So equation goes like s is equals to half at square, because u was equals to 0 and distance traveled was 9 meters by the train extra. Half into a is 2 and t square. So this gets cancelled. T square is 9. So t will become 3 seconds. Okay. And then you have to calculate the distance traveled. So distance traveled is v into t. That Yashwant got wrong. Okay. And what is v? What is v? We just saw that v is 80. 80 into t. Right? So it is 80 square. Understood? And what is t? Half into a into t square is s. So t square is 2s by a. Put it here. 9 into 2 into s by a. This a will get cancelled. So 2 into s is 9. That is 18 meters. This is where Yashwant was getting incorrect. Yashwant, check your answer here. It is 18 meters. Yeah, go on.
Can you teach it once again, sir?
Exactly. See here, basically the thing was that when we go on to the theoretical part, that was saying that this train and the man was 9 meters behind the train's door, basically, right? And at this particular instant, the train started itself with an acceleration of 2 meters per second square. And man started with a velocity Vm. Okay, man did not accelerate, it started with a constant velocity Vm. Right? Now, after t time, they both should be at the same place so as to catch each other. They both should be at the same place. Right? So man traveled a distance of 9 plus s meter in the same t time. And train only traveled this s meter distance. And that is half at square. Understood? Yes or no?
Yes, sir.
Okay. Second, you forget these things. Second concept that we used was at the crossing when they are overtaking each other or when they are at the same point. If they are at the same point, so velocity attained by the train should be equal to the velocity attained by the man. Velocity attained by the train was what? V is equal to u plus at. Initially the train was 0, so velocity of train was a into t, and velocity of man was v only because he was traveling with a constant velocity, right? So from here what we can infer is that at is equals to vm. Point number 2. Understood or not?
Sir.
Point number 3. So extra distance traveled is half into a into t square, and that distance is 9 meters, right?
Yes, sir.
Right? Now see here. So 9 meters is half into a into t square. Half got cancelled with acceleration a and t square. From there we got that it is 3 seconds required to the man to catch the train, right?
Yes, sir.
Agree?
Yes, sir.
Or we can say one more thing. Distance traveled by train was what? Only half at square. And distance traveled by man was what? Distance traveled by man was what? Distance traveled by train plus 9 meter, that is distance traveled by man, that is v into t. Vm into t. Yes or no? Train plus 9 is equals to man, because man was 9 meters behind, so it has to travel the distance which was traveled by the train and plus 9 meter also. Say yes or no?
Yes, sir.
So if we include this, so at square by 2 plus 9, that is equals to vm. We already have done, that is at only 80 into t. We just saw here that vm, velocity of man, should be equals to 80. So 80 into t, if you solve this, you'll be getting 80 square. I'm taking LCM 2 plus 18, that is 280 square here. So from here, if you take 80 square this side, so 18 is equals to 280 square minus 80 square. So that means 18 is equals to 80 square. A was 2. A was 2. If you put the value of A, 18 is equals to 80 square. A was 2. 2 into t square. T square is 9. T is equals to 3. Here also you can get the same thing that we got from here. Understood or not? Yes or no?
Yes, sir.
Next, the distance traveled, that was to be calculated what? Vm into t. So Vm is what? A into t, at square. A we know that is 2. T square we calculated from here. 2s by a. And that was 9 meters only. So we got 18 meters total distance traveled. So we calculated everything. Now, did you get this or not? Tell me. This is a big question. If you revise it once again, you'll get this. Understood or not?
Yes.
Solve more questions. These are the basic questions of JEE. If JEE is merciful, then they'll ask such questions. Okay then, solve more questions, get more doubts. We'll be waiting in the next class. Bye till then. Thank you, sir.
Thank you, sir.